Yeah, hi, my dear students. In this video, I'm going to explain you about how to draw the shear force and bending moment diagram for a simply supported beam, which is loaded with a UDL and a point load. So this will be a very interesting problem because after drawing the shear force diagram, you will see how interesting this thing. Now, before starting the shear force and bending moment diagram, the first thing what we need to do here is we have to find out the support reactions. So for that thing, I have drawn the beam here once again. So at point B, let us call this one as reaction RB, and at point A, let us call there is a reaction RA. Now, if I consider the entire system is to be in the state of static equilibrium, then it has to satisfy three different conditions: sigma fx equal to 0, sigma fy equal to 0, and moment taken at any point should be equal to 0. As there are no horizontal forces acting on the beam, I am neglecting the first equation. Let us go with the second equation. Reaction RA plus reaction RB is equal to the total load which is acting in the downward direction, that is plus 20 plus 10 multiplied by, it is acting over a span of 2 meter. So this is 1 meter and 1 meter, 10 multiplied by 2. So reaction RA plus reaction RB is equal to 10, 2 is 20 plus 20 is plus 40 kilonewtons. Now let us take moment at point A. Sigma moment taken at point A is equal to 0, or you can also take moment at point B. If I take moment at point A, then we have reaction RB that is rotating in clockwise direction, so it should be taken as negative minus RB multiplied by 4 meter plus 20 multiplied by 2 plus 1 is 3 meter, and plus 10 multiplied by 2 meter. It is located exactly at distance of 1 meter. It is equal to 0. Now RB multiplied by 4 is equal to 20 multiplied by 3 is 60 plus 10 to is 20. So we have totally 80 kilonewton. So reaction RB will be equal to 80 divided by 4, which is equal to 20 kilonewton. So reaction RB, we got that one as 20 kilonewton. Similarly, I can calculate reaction RA. RA plus RB is equal to 40. So substituting RB in here, we get reaction RA, which is also equal to 20 kilonewton. So reaction RB is 20, reaction RA is also equal to 20. So we got two reactions here. Now let us go to the problem. So reaction RB, this is 20 kilonewton, and reaction RA, this is also equal to 20 kilonewton. Right. Now what I'm going to do here is I'll take a section in between D and A. I'll take a section in between D and A, and let us call this section as 1 and 1. Section 1 and 1. Now this section is located exactly at distance of x from point A. Now shear force at any section 1 and 1 will be equal towards right side of the section. I'm going to take all the forces, algebraic sum of all the forces. As you know, the shear force is the algebraic sum of all the unbalanced vertical forces acting towards left or right side of the section. I'm taking right side of the section. We have 10 kilonewton acting over a span of x, and we have 20 kilonewton. 20 is acting in the upward direction, should be taken as negative. 10 kilonewton per meter acting over span x should be taken as positive, as it is acting in the downward direction as per the sign convention which I have explained you. Now shear force at any section 1 1 will be equal to plus 10 multiplied by x minus 20. So shear force at 1 and 1 will be equal to 10 times x minus 20. Now I would like to calculate the shear force at point A. Shear force at point A, that is shear force at x is equal to 0, will be equal to minus 20 kilonewtons. We got minus 20 kilonewton. So now from this problem onwards, I will directly draw the shear force and bending moment diagram. After each and every point, I'll mark out the shear force and bending moment diagram. Without any delay, I'll show it here. The first thing is we need to draw the baseline. I have drawn the baseline. Now exactly at point A, I got the shear force, that is minus 20. I'm marking minus 20 over here. For your convenience, I'm marking it as minus, right? Actually, we should not place minus here, as we're dropping it in the downward direction. I mean to say in the downward direction should be taken as negative. Okay, I got this thing as negative. Next, let's calculate shear force at point D. That means shear force at a distance of x is equal to 2 meter. So this is plus 10 multiplied by 2 minus 20. So it is equal to 0. See, at point D, exactly at point D. Here is point D. Shear force, it is equal to 0. Now there is no other point in between C and D, hence I can directly take at point C also the shear force will be equal to 0. But I'm not writing down it here. What will be the shear force from point A to D? It will be linear, right? Linearly varying. So this is negative. This is negative. So this is one of a kind of problem where you can see shear force which is equal to 0 over a particular span. Next, in the similar manner, let us calculate bending moment. Bending moment in between the section 1 and 1. So it is equal to, so this 10 kilonewton per meter acting over a span of x will be pushing it in the downward direction, so it has to be taken as negative. Minus 20 into x by 2 is the force multiplied by perpendicular, x by 2 is the perpendicular distance. Next, 20 kilonewton is trying to push the beam in the upward direction, so it has to be taken as positive, as it is creating some positive bending moment. Plus 20 multiplied by x. So bending moment at any section 1 and 1 is equal to this 2, right? It cancels for 10, minus 10x square plus 20x. So you can see the variation over here, right? So it is a square, so the variation will be parabolic. Now bending moment at any section x is equal to 0. That means bending moment at point A, that is 0. When I substitute x is equal to 0 here, you will get the value as 0. Now bending moment at any point x is equal to 2 meter. That means bending moment at point D. So it is minus 10 multiplied by 2 square plus 20 multiplied by 2. So this is minus 10 multiplied by 4 plus 20 multiplied by 2. 10 fours is 40, and this one is again, which is equal to, so there is a small correction here. Actually this is 10, not 20. 10 into x divided by 2. So this will be 5x square divided by 2. So this is 5x square plus 20 times x. So bending moment at point A is 0, as we have substituted x is equal to 0. Bending moment at point 2 meters, right? Bending moment at point A will be equal to 5 times x square plus 20 times 2. So this will be equal to 5 times 4 plus 20 multiplied by 2. This is minus 20 plus 40. It is equal to plus 20 kilonewton meter. Right. So I'm marking out the points here, right, for bending moment. At point A, it is equal to 0. And exactly at point D, we got the value. That means exactly at point D, the bending moment is 20 kilonewton. So over here, so this is 20 kilonewton, and we have the variation of bending moment as x square. So the variation here will be parabolic. So this should be a parabola, and I'm marking this one as positive. Now similarly, let us consider a section in between C and D. If I consider a section in between C and D, let the section be 2 and 2. I'm just calling this one as section 2 and 2. This is located exactly at a distance of x. It is located exactly at a distance of x. Now shear force for section 2 and 2 will be equal to algebraic sum of all the forces acting towards the right side of the section. So this is negative, this one will be positive. Minus 20 plus 10 multiplied by 2 meters, right? So it is acting over a span of 2 meters. So it will be equal to 0. That means shear force at point D is equal to 0, and from point D to point C there are no other forces, and shear force at point C will also be equal to 0. Now same thing again, as I told you earlier, at point C shear force is equal to 0. I have marked here, right? So it will be a straight line which is touching the baseline. Now bending moment, right? Bending moment at any section 2 and 2, it will be equal to whatever the forces you are seeing here. 10 kilonewton per meter is acting in the downward direction over a span of 2 meter, but the perpendicular distance what we have to consider here, right, it will be x minus 2, right? So whatever the distance you see here, x minus 2 divided by 2, I mean to say x minus 1. This total distance is x, from which 1 meter is gone, so this will be x minus 1 meter, x minus 1 meter. So I'm going with the first one here, so this will be negative, minus 10 multiplied by 2 multiplied by the perpendicular distance is x minus 1. Perpendicular distance is x minus 1. And the next one, we have 20 kilonewton here, so it is pushing the beam in the upward direction, should be taken as positive, plus 20 multiplied by x. Now bending moment at any distance x is equal to 2 meter. That means bending moment at point D. So this will be equal to minus 20 times 2 minus 1 plus 20 into 2. So this is minus 20 plus 40, that is equal to plus 20 kilonewton meter. So already we have plotted 20 here, right, at a distance of x is equal to. Now let us calculate bending moment at a distance of x is equal to 3 meter. That means bending moment at point C. So this will be equal to minus 20 multiplied by 3 minus 1 plus 20 multiplied by 3. So this is minus 20 multiplied by 2 plus 60. So this will be again equal to 20 kilonewton meter. So bending moment at point C, it is equal to 20 kilonewton meter. So up to point C, it will be same again. So I'm just marking out here at point C, it will be equal to 20. And there is no need to calculate the bending moment at point B, right? Obviously you can directly join the line, because bending moment at point B for a simply supported beam, right, at the end it will be equal to 0. And shear force at point B, right, there is a small note which I gave you in the previous classes, that at point B where there is support, right, shear force will be equal to the support reaction, right? And shear force at A is 20 and shear force at B will be equal to plus 20, right? So this one is negative, this one should be positive. If I consider towards the right side of the section, left side of the section. So obviously I'm marking plus 20 over here, this is plus 20, and the variation between these 2 points will be linear. So this should be taken as positive. But there is a small mistake here, right? So actually it will not be the triangle. As you can see, there are no other forces in between these two things. So it will be a parallel line which is parallel to the baseline. So it will be a parallel line up to here. So this is the correct one. This one should be here. It looks like a box. That's it. Thank you.